Good morning students. Today we are going to cover a new topic from the statistical aspect, that is SEM 3 paper 2 unit 4. The name of the topic is analysis of variance, that is one way as well as two way analysis we have to cover today. So what is Anova? Anova is nothing but, its full form is analysis of variance. A stands for analysis, AN stands for analysis, O stands for of, and VA stands for variance. So what is the full form of the Anova? That is nothing but the analysis of variance. I repeat, AN stands for analysis, O stands for of, and VA stands for variance. So what is Anova? So Anova is the statistical technique, एक ऐसा प्रकार का टेक्निक है which is used to compare the means of variations of more than two sample, and it is called the analysis of variance. मतलब ये एक ऐसा प्रकार का statistical aspect है and it is used to compare the means of variation. हम क्या करते हैं? means of variation of more than टू सैंपल. जब दो और दो से ज़्यादा सैंपल अगर हमें एनालिसिस करना है, उनमें वेरिएशन कितना है फाइंड आउट करना है, देन दिस टाइप ऑफ एनालिसिस इज utilized. So you can say that Anova is a technique which is used to compare the means of variation of more than two samples. दो से ज़्यादा सैंपल के एनालिसिस के लिए हम Anova का टेक्निक यूज़ करते हैं. Now it is a powerful statistical procedure for determining if the difference in the mean are significant. म्हणजे एक ऐसा प्रकार का प्रोसीजर है इन विच हम क्या करते हैं, डिफरेंस इन द मीन, एक ग्रुप के अंदर वाला मीन, एक ग्रुप का मीन या फिर विद इन द सैंपल एंड बिटवीन द ग्रुप्स, मीन ऑफ बिटवीन द ग्रुप्स ये सिग्निफिकेंट है कि नहीं, ये फाइंड आउट करते हैं फॉर डिवाइडिंग द वेरिएंस इनटू द कंपोनेंट्स. सो इट हेल्प्स इन एस्टिमेटिंग whether more variation exists among the group means or within the group. हम क्या करते हैं, we used to estimate, हम find out करते हैं वेरिएशन विद इन द ग्रुप आहे या फिर विद इन द ग्रुप है या फिर इन बिटवीन द ग्रुप्स है, एंड द रेशियो ऑफ दिस टू वेरिएशन is denoted by F because it was introduced by R.A. Fisher. So we used to find out the ratio of the F. And what is the ratio of the F? And the F ratio is nothing but it is an indication of differences between the samples. So we used to estimate by means of the F ratio or the F value. We also call it as F value. Therefore the table we used to follow is F value or the F ratio, and it was first introduced by the R.S. Fisher. So Anova, that is analysis of variance, it is nothing but it is a powerful statistical procedure for determining if differences in the means are significant or not. Now normally the Anova is of two types, that is one-way Anova and the two-way Anova. Before that we must know the variance. So what is variance? Variance is an absolute measure of dispersion of raw score around the sample mean. सो इट इज़ रॉ स्कोर अराउंड द सैम्पल मीन. सैम्पल का जो मीन होते हैं उसके अराउंड के डिस्पर्शन या फिर रॉ स्कोर को हम यू कैन से दैट it is a type of dispersion around the sample mean, that is said to be the variance. And what are the techniques for analysis of variance? Normally I say that ANOVA can be estimated by means of two-way, that is one-way ANOVA or the two-way ANOVA. The first one is said to be the one-way ANOVA. So what is one-way ANOVA? It is nothing but the single independent variables are involved. In case of one-way ANOVA, only one independent variables are involved. But in case of two-way ANOVA, here two independent variables are involved. That's why it is said to be one-way ANOVA or the two-way ANOVA. Always keep in mind that, remember that one-way means one independent variable and two-way means two independent variable. For giving one example, that is effect of pesticide on the oxygen consumption in the sample of an insect. Here the effect of pesticide is an independent variable and on the oxygen, that is oxygen consumption, is the dependent variable. So what are the effects of pesticide on oxygen consumption in a sample of insect? So if we apply a particular pesticide, so what are the effects of these pesticides on the insects? So here only one independent variable is present, that is pesticide. And what is the dependent variable? Pesticide is affecting the oxygen consumption of the insect. So this pesticide is dependent on the, or oxygen is dependent on the pesticide. So pesticide is independent, you can say that it is independent variable and oxygen is the dependent variable. Now coming up to the two-way ANOVA. Here in case of two-way ANOVA, here two independent variables are involved. Example for that is effect of different level of combination of pesticides. So here what we did is that we have taken different pesticide and then we have mixed it up. So we got the particular mixture of pesticides. So we have taken different level of combination of pesticide and insect hormones on oxygen consumption of a sample of insect. Here you can see that pesticide is an independent variable as well as insects hormone are the independent variable. So here two independent variables are involved and oxygen consumption, it is nothing but the dependent variable. So here also in case of one-way ANOVA, we have taken pesticide as independent variable and oxygen as a dependent variable. Here only one independent variable is involved. But in case of the second example, that is two-way ANOVA, here you can say that two independent variables are involved. That's why they are said to be two-way ANOVA. Now coming up to the one-way ANOVA. For computation of one-way ANOVA, for the computation of ANOVA variances is estimated at two different levels. First one, that is population variance between the groups. So if two different groups are taken, so what is the population variance between the groups? Here we have taken the groups and what is the variance between these group is taken. And next is population variance within the group. So inside the group what are the different variants? So computation of one-way ANOVA can be done by means of estimated at two different level, within the group and between the group. Now coming up to the working procedure. The procedure of calculation in direct method are lengthy, and these methods, or you can say that if we follow the direct method, the direct method is so lengthy as well as time consuming. It is time consuming, and this is not popularly practiced for all purposes. So you can say that this method is not adopted in case of Anova. So instead of direct method, a shortcut method is applied. Therefore, a shortcut method based on sum. This is SUM. So the direct shortcut method based on sum of the squares of the individual value is usually used. So you can say that instead of direct method, shortcut method is utilized in case of Anova, and this method or shortcut method is more convenient. Shortcut method is utilized and it is most convenient. So this method is utilized, shortcut method is utilized, and is because it is convenient. Now coming up to the steps of calculation. So we have to follow 9 steps for the calculation, and we'll go one by one. So in case of Anova calculation, you have to follow one step with the another step with the another one. Suddenly you cannot fall or come to the conclusion. You have to follow this step one by one, and in this way we are going to calculate the Anova. So what is the first step? First step is step up the null hypothesis and the alternative hypothesis. The first step is, first we have to set up the null hypothesis and the alternative hypothesis. This is the first step. So just we are going through the different steps, and later on while calculating or solving the examples you will come to know what is null hypothesis or the alternative hypothesis. Next is calculate total, that is T, of all the observation. This is nothing but the observation. So we have to take the totaling of all the observation in all samples. So T can be calculated as T is equals to sum of, consider if the first sample x variable, that is summation of x1 plus summation of x2 that is summation of x2 summation of x2 plus summation of x3. Similarly, we have to calculate till the summation of xk. The number of observation what you are given, so we have to find out the variable summation of all the variables. Next, third step, we have to find out the correction factor. Correction factor, that is can be calculated by means of t square by n. Next step, that is calculate sum of square deviation. Sum of the square deviation, that is sum of square deviation can be abbreviated by means of SS and capital T. So S is nothing but the sum of square deviation, that is SST. So SST can be calculated by means of summation of x1 whole square plus summation of x2 whole square plus summation of x3 3 whole square. In this way we have to sum of x3 whole square. In this way till we have to add sum of k number of observation is there. Therefore the last observation, that is summation of x k whole square minus t square by n. T square by n. In the third step we have calculated the t square n. So we have to follow this stepwise step, and then only we are going to calculate the next step. So here we will get whatever the answer we'll get, we have to minus it, subtract it from t square n from that. So in this way we are going to calculate the SST. Next, the fifth step. Now calculate sum of square of deviation between the samples, that is SSB. So what is S? Is sum of square of deviation. B is deviation. So how it can be calculated? It can be calculated by this formula, that is sum of x1 whole square by n. We know that standard deviation can be calculated by means of square root of x summation of x square by n. So here we have to calculate this sum of square of deviation. So deviation we have squared it plus summation of x2 whole square by n square plus this is n1. So in order to find out the SSB, that is sum of square of deviation, we have to find out by this way, that is summation of x1 the whole square by n1, that is the first observation, n1. Next is summation of x2 the whole square by n2, next observation, that is total number of observation, plus summation of x3 third variable whole square divided by n3, next observation. And in this way till how many observation is given, that summation of x square k by nk, nth number of observation, minus the whole, this whole, minus t square by n, t square by n. So we have to find out the sum of square of deviation SSB by this way, and whole minus t square by n. So third step is very important in calculating the SST. What is SST? Sum of square of deviation. And this is nothing but the fifth step, that is sum of square of deviation between the sample. So here we have calculated sum of square of deviation total, and here we have calculated sum of square of deviation between the sample, in between the sample, एक sample के अंदर में deviation find out करना है, that is nothing but the SSB, and totaling of sum of deviation of all samples, that is SST. So rest of the step, that is step 5th, 6th, 7th, 8th and 9th step we are going to discuss it tomorrow, as well as the example. Thank you for watching.